So we will continue our lesson. We already started, we mentioned about motion with constant acceleration, and we derived this equation V final equal to V initial plus acceleration times time. We already explained it, the meaning of this equation. Now, as you see in this equation, there is no any information about distance, displacement. We have a relationship between final velocity, initial velocity, acceleration, and the time. It means this equation, this formula is not enough for us to solve this kind of problems. So we need to continue. We need to derive another equation, at least one equation, which should be related to the distance, displacement. So basically this is a final velocity, or this is a velocity after t time. In terms of mass, we can rewrite it in different form. V in brackets t equal to V1 plus AT. It's totally same two equations, just we are using two different symbols. Or we can keep it simple and we can say V equal to V initial plus AT. Totally same equation. Instead of V2, I use just V, which means final velocity or velocity after t time. Now let's go back to the definition of the velocity. What is the velocity? The original definition or original equation formula for velocity is equal to delta x over delta time. A derivative of x with respect to the time, basically. So this is a original equation, and you can use this equation, this formula, for any type of motion. It can be motion with constant velocity, it can be motion with constant acceleration, it can be totally different unknown motion. It doesn't matter. You can use this equation for any motion, that's all. It means we can also use it for this situation, for motion with constant acceleration. So let's use. So V equal to this one, V1 initial velocity plus A times t equal to delta x over delta time. This is derivative basically. From here, delta x equal to V1 plus AT times delta t. So first is totally mass. It's not physics. Physics only here. This part is physics. We substituted first equation, that's all. Further is just totally mass. And as this is the integral equation, basically, I will keep it simple. X equal to integral, we can open this bracket, so it will look like V1 delta t plus AT delta t. Or we can write it in this way, V1 delta t plus integral AT delta t. Okay, let's continue. This part, V1 is just number, constant number. Integral of V1 delta t. So we will, it will be equal to V1t. That's all. Integral of this part. And the integral of this part will be equal to a t square over 2. And of course, plus constant, any number. For now, it's any number. We don't know. So as you see, we already derived equation formula for the x, and x is a displacement, position, distance. So the meaning of constant number here actually initial position. We can prove it, but we will keep it very simple for now. Final position equal to c is a constant number in terms of mass. Its physical meaning is initial position, so let's call it x1 or x0, it doesn't matter, equal to v1t plus at square over 2. So don't forget, this equation you can use only for motion with constant acceleration. Final position, initial position, so final position minus initial position will be equal to v1t plus at square over 2. As you know, final position minus initial position equal to what? Displacement. Again, delta x. Or sometimes to keep it simple, we just say x, but don't forget it's a displacement. So we derived our second equation. Displacement equal to initial velocity times time plus at squared over 2. So for motion with constant acceleration, we already derived two equations, and by using these two equations, by combining these two equations, we can come up with a third equation. Let's see what kind of formula equation we have. So if we pay attention here, there is no any information about distance, displacement. Here there is no any information about final velocity. So let me combine these two equations and let's see what we can get. Let me create new page. From the first equation, time equal to final velocity minus initial velocity divided by a. And let's substitute it into the second equation. So x, basically this x, delta x. Let me keep it simple. This x is not position, this is a displacement. Initial velocity time plus 1 over 2 at squared. I will use this time in this equation. So x equal to v1, v2, further is totally mass. I will just keep writing. So here we need to multiply by 2. And we should be very careful here. We need to simplify. As you see here, we can lose this part, and here we have a minus v1 square. That's all. Let's see. X equal to 2a v2 square minus v1 square. So 2ax equal to v2 square minus v1 square. Or we can write it in this way. V final square equal to v initial square plus 2ax. So this will be our final equation formula for the motion with constant acceleration. Now let's summarize. Motion with constant acceleration. We can use three equations. V final equal to v initial plus at. Second one, v final square, v initial square plus 2ax. And x displacement equal to initial velocity time plus 1 over 2 at squared. We already explained it, how to derive these equations. Now we should be very careful, and we should pay for some physical quantities, and it's very important. Velocity here is velocity, not speed. Be careful. It means you should pay attention to the direction of the motion. So here in this equation, for example, this v2, v final or v initial, it can be negative number. Why? Because it's a velocity. Acceleration, also it can be negative sometimes, because acceleration is a vector quantity. It has a direction. And the same for other two equations. Here displacement. As you know, displacement is a vector. It's not distance, it's a displacement. Again, displacement, it can be negative. So before using these three equations, first of all, you should choose or specify the direction, or sometimes we call it axis, x-axis, y-axis. Usually we say x-axis opposite to the right side, y-axis, vertical axis, positive to the upward. This is what you will be using during the solving problems. That's all. So if, let's say you have a car, if it's moving to the right, let's say initial velocity, it means you should use positive number for v1 because it's moving to the right. If it's moving after some time, it's here and it will be moving to the left, for example, it means here you should use negative number. Negative about direction because it's moving to the left side. Number, it's a magnitude, 10 meters per second, for example. Same for the acceleration. If this car is accelerating to the right side, it means your acceleration should be positive number. Then displacement. For example, this is a starting point, this is a final point. Displacement is directed to the right, as you see. Final point is at the right side of the initial point. So displacement, x should be positive number. If it shifts to the right side, it means displacement will be negative. So let's summarize again. We have a motion with constant acceleration. In this case, we can use three main equations, and we already explained how to derive these equations. And let me explain another method of solving physics problems. These three equations, at last, it's a mathematical equations. It means we can explain it in terms of graphs. So let's draw some graphs. Of course, there are so many types of graphs. Here, let it be velocity against time, meter per second, for example, and let it be acceleration versus time, and maybe we can draw displacement time. So let's start with the first equation. As you see here, in terms of mass, it's a totally same with this one. For example, y equal to x plus constant number, or not constant number. Constant number is v1. So a is a v1, let it be any number, 10 minus or plus, t is variable, in this case it will be x. So there is no any difference between these two equations. So instead of y-axis we have a velocity, instead of x in horizontal axis we have a time. So this is a graph or same explanation as the first equation. This will be initial velocity v1, then it increases. So what we have here, straight line, not horizontal, not vertical, basically inclined plane, but it's a straight line. So we can draw this kind of triangle in terms of mass, in terms of geometry. This is a right triangle, and this part equal to v2 minus v1. So this part is final velocity. So this length, this side of the triangle equal to v2 minus v1. This part basically equal to time because it starts with 0 time. So this side of the triangle equal to the length of the triangle equal to t basically. So pay attention, we have a right triangle here. This is a right triangle. Let me highlight it. And as you know, for any triangle, we have angles here. Let's use alpha. So what is the alpha? Tangent alpha, for example. Tangent alpha equal to opposite side, which is V2 minus V1, divided by this side, which is T. So tangent alpha in terms of mass equal to V final minus V initial divided by time. So this is in terms of mass. So we have a mass glass. This is what mass students see. Now let's try to describe it in terms of physics. What is the physical meaning of this tangent alpha? So if we pay attention to the first equation, V2 minus V1 over time will be equal to acceleration. So it means the physical meaning of this tangent alpha is acceleration. That's all. So let me highlight it again. What does it mean? It means if you have a velocity time graph and the slope is a synonym of the tangent alpha. If you somehow calculate tangent alpha, it will be equal to acceleration. Now let's continue. This is a right triangle O, and O. If you remove all this stuff, if I draw this kind of line, vertical line, so what we can see here, we have another mathematical or geometric figure. Let's find its area. Let's see. Maybe we can come up with the physical meaning of this area. For now, we don't know. Let's check. So in order to find the area of this figure, there are so many methods. Let me keep it simple. Let me divide it into different figures. Upper part is a right triangle, and here is rectangle. Why? Because it's simple to find its area, that's all. Area of this part, as you know, this side, which is V2 minus V1, times this side T, divided by 2. This is the area of the triangle. And the area of this part is rectangle, so V1 times T. V1 times T. So total area under this line, this was our graph, will be equal to area V1T plus V2 minus V1 times T over 2. Let's see what is, can we explain it in terms of physics? Let's try. Here, what we can see, V2 minus V1, which can be described as A times T here. So V final minus V initial equal to A times T. So let me replace V2 minus V1 with AT. Area equal to V1 T plus A times T. This is a V2 minus V1. And the times one more time over 2. And finally, area equal to V1T plus AT square over 2. So this is basically totally same with this equation. V1T plus AT square over 2. So the physical meaning of this area actually equal to what? Displacement. Displacement. It means if you have a VT graph, if you can somehow determine the area under the line, the physical meaning of the area will be equal to displacement.